Good afternoon. I am Bhagyesh Deshmukh from Walchand Institute of Technology, Solapur. The topic over here right now is spur gear. In spur gear, we are discussing the beam strength and wear strength. Let us begin with the nomenclature of the spur gear. For a spur gear, as we know, in the nomenclature, major important terms are, say, circular pitch. I am showing the points. Then addendum circle and the outermost edge. Then the pitch circle, the virtual contact zone, base circle, and the dedendum circle. The mating gears are shown in the next figure. The figure is regarding the terminology. The important terms are discussed in this figure. Working depth is presented over here along with the clearance which is in between the two mating teeth. Hole depth is also mentioned for the tooth depth, tooth space in between, important term fillet radius, as well as the tooth thickness is presented. Gear design means to find out the module. For module, say the examples are shown. M equals to millimeter, 3 millimeter, 4 millimeter, 5 millimeter. This is how the proportion depends on module is shown by the sketch. There are two choices of module. Choice 1 is called as a preferred and choice 2 is the second choice. In choice 1, 1.25, 1.5, 2, 2.5, 3, 4, so on up to say 20. These are the standard module values. The cutters are generally available in the market and are preferred. For module selection, we need to find out the beam strength and wear strength, and these needs to be evaluated and compared. Important equation for gear design is Levy's beam strength equation. For Levy's beam strength equation, the tooth is considered as a cantilever beam. Here we can see the support zone and this is the cantilever beam. We can see that this is the distance h of the beam. B represents the face width of the gear and Pt is the tangential force which is distributed uniformly over the length of or over the entire width of the gear tooth. If I check the gear force analysis, the dotted line over here shows the force acting, resultant force acting on the gear tooth. If I resolve the forces into two, Pt is the tangential force which is responsible for drive, and Pr, which is directed towards the center of the gear, is the radial force. Tangential force Pt plays an important role while calculating the power to be transmitted or the rated power of the gear. Few assumptions are required in the Levy's beam strength equation. The assumptions mentioned are effect of radial force Pr is neglected. This Pr is neglected. Next one, the tangential component Pt is uniformly distributed over the face width. Here in this sketch we can see that tangential force is uniformly distributed over the entire face width. Next, the effect of stress concentration is neglected. And important is, at time, only one pair is in contact and takes the entire load. The formulae for the two forces, tangential force is given by 2mt upon d dash, where this is the usual formula, torque equals force into the perpendicular distance or the radius. Radial component, however, is given by Pr equals Pt tan alpha, where alpha is the pressure angle. Bending moment is given by Pt into h. Then I value is given by 1/12 Bt cube, it is a standard rectangular cross section. Tangential force, the value is given by mb sigma by, where m is the module, b is the face width, sigma b is the bending stress. Permissible stress can be given as SUT. We can get sigma b by SUT by 3. And y is the Levy's form factor. This is given as t square upon 6hm. When I say that the maximum value of tangential force is reached, it is called as the beam strength. The equation seems to be same, but SB is the maximum value of PT. Next is the wear strength. For wear strength, two cylinders are considered. These represent the sector of the gear tooth, and this zone is under compression. Therefore, it is evaluated as a contact stress by contact stress check. Contact stresses are shown at the contact point of the tooth. Wear is considered to be an important issue for gear tooth. The wear strength equations are given by SW equals BQ dPk, where B is the phase strength, as already mentioned, dP is the pitch circle diameter, and Q is 2Zg upon Zg plus Zp, and K is given as sigma c square sin alpha cos alpha 1 upon E1 plus 1 upon E2 upon 1.4. Using these equations of beam strength and wear strength, we can find out the beam strength and wear strength. We need to compare these two, SB and SW, in order to decide what is the criteria of failure. For this section, I had used the reference as Design of Machine Elements by V.B. Bhandari, Tata Micro Health Application. Thank you.